Okay, so this next problem is also one that you would have seen in Algebra 2, right? So it says if you have the secant of something as this, where sine is greater than 0, find the exact values of the remaining 5 trigonometric values. So we're going to do this by drawing a triangle, all right? So we're going to draw a triangle, a right triangle, okay, with an angle theta. So what this is telling you is there's this mystery angle theta, and if you take the secant of it, you get root 21 over 3. Well, we know that secant is hypotenuse over what? Adjacent. So in this triangle theta, hypotenuse over adjacent is root 21 over 3. So now I can find the missing side. 3 squared plus x squared is equal to root 21 squared. So 9 plus x squared is 21. X squared is what? 12. So x is root 12, which is how much? 2 root 3. So that's x, 2 root 3. Fabulous. Now, we're also given another piece of information here. We are told that sine is greater than 0. So now what we do, sine is greater than 0 means sine is positive. So now what we do is we use that piece of information along with this one, okay, to determine which quadrant our angle is going to lie in, right? So we're going to use these together to determine quadrant, okay? And the way in which we do that is the following. So here is the unit circle, okay? So here, this second one here is saying sine is positive. So is sine associated with the x or the y? The y. And so in here, positive y's are all here, right? So sine is positive in the first two quadrants. So I say, okay, positive here, positive there. Then I'm also given secant is some positive number, right? So use like the plus minus, that SIGN sign of the secant. Secant is like cosine. Cosine is like the x's. It's positive here and here. When you do this, do you have a question? Oh, I thought you had a question. When you do this, there's going to be one quadrant where you're going to have two symbols in there. Okay, there's always going to be one quadrant with two symbols in there. In this case, it happens to be quadrant 1. So we know that the angle is in quadrant 1. Okay, so one thing, just to remind people, the way you can figure out the quadrants is also by this mnemonic called all students take calculus. So if we go back here, I kind of like brushed past this yesterday. All students take calculus. Okay, so this is the phrase that we use. It doesn't have to be a correct statement. It just has to work in our math, right? So all students take calculus. It works like this. All students take calculus. Okay, just go counterclockwise. Now, the A in math stands for all. The S stands for sine. The T stands for tangent. And then this C stands for cosine. So basically, the way this works is if you have an angle in this quadrant, this is the quadrant of the S, of the sine. If you have an angle in this quadrant, and if you take the sine of the angle, it'll be positive. Everything else will be negative. Tangent of this angle, negative. Cosine of this angle, negative. All right? If you have an angle here, which one of it will be positive? The cosine of this angle will be positive. The sine will be negative. tangent will be negative, okay? So going back here, we are told secant is positive. Secant is like cosine. Where's cosine positive? All, right here, all students take calculus, cosine here. So here and here, okay? All right, so now we know that the angle is in quadrant 1. Now we need to find all of the other angles. So sine of theta, just going on the triangle, sine of theta is 2 root 3 over root 21. Okay, this one, you need to simplify it, all right? Because you have two roots that are being divided with each other. That's the same as 2 root 3 over 21. Oh my God. So this is 2 root 1 over 7. Is that right? Which is 2 times root 1, 2 over root 7. Is everybody okay with that? You have to do this. You don't have to rationalize.
I was going to say, like, you have to do all, like, the theory. Can you just go straight from
You can go straight. You can go straight. I was just showing the process. Absolutely, you can go straight. So cosine of theta is 3 over root 21. That's simplified. Tangent of theta is 2 root 3 over 3. Cosecant of theta, okay, now just take the simplified version, root 7 over 2. Secant of theta, we're already given root 21 over 3. And then cotangent of theta, 3 over 2 root 3. And we're done. All right? Yes. Yep.
Why is
The quadrant matters in the following way. Because everything is in the first, because it was in the first quadrant, that means all of these have to be positive. Now, yes, suppose you are in this quadrant. In that quadrant, which one is positive? Tangent. So then everything else, you would have to make it a negative, right? Correct. Now, right? But like, it can't be in that quadrant because, well, it's just not. Okay, and now I'm like committed to this. I can't erase this. Okay. My eraser doesn't work. Now people are going to think I made a mistake. Okay, these are definitely positives, okay? All right. Why doesn't my eraser work? Oh boy. Oh my God. Are you kidding me? Fine. Okay. Okay. Cosine of 60 is equal to sine of what? I think you had one of this on the homework, right? It slipped by. Yeah. So cosine of 60, right? On the unit circle, cosine of 60, it's this little side, a half. So now sine of what angle is a half? That's 30 degrees. Okay. Here we go. Use the given values to evaluate the trigonometric function. So we have sine of negative theta. So put a star next to this problem because it's important. And there's a reason why it's here, because it's leading to what we're going to do in another chapter, in the next chapter, okay? Everything here has a reason for being here. Okay, so we are told sine of negative theta is 5 over 9, okay? What is sine and what is cosecant? Okay, so let's think about this for a minute. This is the unit circle, right? So suppose you have an angle theta, okay? It's like 30 degrees, 50, whatever. Where would negative theta be? Right here, right? That would be negative theta. Now, let's think about that word negative, okay? So suppose x is negative 3. How much is negative x? Positive 3. So when you have like negative theta, it just means theta of the opposite sign, right? For instance, suppose my original theta wasn't that. Suppose my original theta was this, right? Now where would negative theta be? Up above, okay? Because if theta was negative 30, then negative theta is positive 30. Okay, now let's think about this for a minute. Here we have theta and negative theta. So if you take theta, let's talk about the sine of theta. So when I make a triangle here, that vertical side is the sine of theta, correct? How much would so suppose this is the point 3 comma 4. How much would the sine of theta be? 4. It's the y distance, right? It would be 4. So now in negative theta, where is sine of negative theta? What would it be then? Negative 4, right? So when you change the angle from theta to negative theta, right? When you take the negative of the angle, it's a reflection around the x-axis, so the y value will switch sign, correct? Right? How clever is that? Yes. Now, let's think about the cosine. What's the cosine of theta, this top theta? It's that distance, 3. How about the cosine of negative theta? It's the same line, like literally the same line. So when you change the angle to its negative angle, what happens to the cosine of the angle? It stays the same. Isn't that exciting? Why aren't you excited about this? Yay. Oh, right? Yay. Thank you. So if sine of negative theta is 5/9, then what's sine of positive theta? Look at you. Okay, and then the cosecant is how much then? Fabulous. Isn't that cool?
That's cool.
It's so cool. This is why we love math, right? Because literally, look, everything you learned in the past about reflection around the x-axis, right? Look at how it's consistent here as well. This is why we love math, because math is harmonious across everything, right? Everything. Yes, there are no plot twists, right? This is why we love math, okay? Because also the laws of math, like the reflection, they're literally like bigger than any of us, right? If the laws of math say a reflection around the x-axis is this, then that's a reflection around the x-axis. It doesn't matter if you're doing trig or what, right? It's bigger than us, okay? All right, so, what a wonderful way to start the morning. Okay, so we'll end here. Your homework, right, is gonna be all the ones that you skipped. So basically you need to have homework number 3 completed. Now, just continue these, just pick up where you left off on your page, right? You don't have to go to a new page because it's all part of homework 3. Okay? All right.